Yeah, so under this recording, I will be explaining integration by use substitution and integration by parts and integration by parts. Parts. So I'm gonna start with use substitution, like because this one is the easiest one. I'm gonna start with the first method of integration, which is use substitution. So let's say you're given this example, the integral of cosine x over the root of 1 plus sine x dx. So with this one, we're going to say let u be equal to 1 plus sine x. So in most cases, we'll let the one that is inside the square root to be u. And the u over the x will be equal to negative, will be equal to cosine x. Therefore, we know that, okay, the x will be equal to the u over cosine x. And then from here, we can now say from the original question, sine x over the root of 1 plus sine x dx. So this will be equal to the integral of cosine x over the root of u. Over the square root of u multiplied by du over cosine x. So cosine x will cancel out with cosine x. Now we'll be having the integral of negative of u to exponent negative 1 over 2 du. And then from there, we know that we have to integrate, we must integrate u to exponent negative half the, then we say what, du. This will be u to exponent negative half plus 1, negative half plus 1 plus c. And this will be half over half plus c. Then if we simplify this, we'll get 2u to exponent half plus c. Then 2. Then now we know the value of u. We said u is what? It's 7 is 1 plus sine of x. So we'll just replace with 1 plus sine of x where there is u. Then to exponent half plus c. Then this will be rewritten as the square root of 1 plus sine x plus c. So this will be the final answer for that question. Then we'll go to the second example. When you have the integral of the cube root of 7 minus x all squared dx. So you're gonna let the one that is inside the square root to be u. And then we differentiate. The answer will be negative 1. And then the x will be equal to negative du. And then from there, you will write from the original equation the cube root of 7 minus x all squared dx. This will be called the integral of the cube root of u squared. Then the x is what? Is negative du. Then this will be the integral of u to exponent 2 over 3 negative du. Then if you integrate this one, you will get u to exponent 2 over 3 plus 1 over 2 over 3 plus 1. Then plus c. And we know that 2 over 3 plus 1 is equal to 5 over 3. Then we'll have 5 over 3 plus c. Then this will be 3 over 5 u 5 over 3 plus c. Then our u will be equal to 7 minus x to exponent 5 over 3 plus c. Right? Yeah, so this will be our final answer. You can write it as well as 3 over 5, mm, the cube root of 7 minus x all to exponent 5 plus c. So this will be our final answer for that question. Then we go to number 3. If you are having the integral of x to exponent negative to exponent n minus 1 over a plus bx to exponent n dx. Here you're going to say let u be what is on the denominator, which is a plus bx to exponent n. So that will be our u. And you notice that if we differentiate u to exponent n, we're gonna get x to exponent n minus 1. And that's what we want. Then we'll say du over dx will be equal to the derivative of a with respect to x. It will give us 0 plus then b, then we'll have this. Then we'll have bn x exponent n minus 1. Right? Then we know that du is equal to over dx. Then we know that dx will be equal to du over bn x n minus 1. Then we'll say from x n minus 1 a plus bx exponent n dx. This will be the integral of and this one we say this u and then dx now is equal to this is du over bn x n minus 1. Now just decide n minus 1. Then this will cancel out with that. Then now we'll be having our constant 1 over bn, the integral of 1 over u, du. Then our answer will be 1 over bn, the mean absolute value of u plus c. Then our answer will be 1 over bn, the mean absolute value, and then our u is what is a plus bx to exponent n plus c. So this will be our final answer, this one. Now, number 4, if we are having the integral of tan x sec squared x dx. So this one you're going to choose whether you're gonna say let u be tan x or sec x. It's up to you. I'm gonna choose tan x. Then we say du over dx will be equal to sec squared x. Then we'll make the x subject of the formula. We're gonna get the x will be du over sec squared x. And then we say from the original question, then this will be equal to the integral of tan x. No, the integral of u, then say sec squared x, and then dx we know is du over sec squared x. Then sec squared x will be cancelled with sec squared x. Then will remain with u to exponent 2 over 2 plus c. When we integrate u with respect to u, then we're gonna have 1 over 2, then u we know is tan x squared plus c. So this will be our final answer. Another way you could have done this is you could have said let u be equal to sec x, and then du over dx of u of sec x is what is sec x tan of x. Then we make the x subject of the formula. We're gonna get the u over sec x tan x. And then now we know that we can replace this where there is the x. We know that the original question was like this. Then we'll have tan x u squared. Since we said let u be sec x, then the u over sec x tan x. Then tan x will cancel out with tan x. Then we'll be left with the integral of u squared over sec x du. But we know that sec x is equal to u du. So they will cancel each other. Then we'll be left with the integral of u du, which will be u squared over 2 plus c. Then our final answer will be x squared x over 2 plus c. So it's either you will be having this one or this one. So it will depend on which u did you use. So now let's go to example 4. Ne? If you are having, I think that was example 4. I think it was let me see. Yeah, it was example 4. So now we'll go to integration by parts. So with integration by parts, we have got this general formula, the integral of u. So firstly, we use integration by parts when we have got what? A product of two functions. If you have to integrate functions which are multiplying each other, ne? Yeah. The integral of u dv is equal to uv minus the integral of v du. So now we know that. So let me give you guys an example for this one. So this is the formula that we're gonna use if we want to integrate. So this one is the general formula. Ne? The general formula. So what I'm saying is if we're having two functions which are multiplying each other, we're gonna use integration by parts. We're gonna have to apply this formula. So now let's say you are given the following example. Ne? And before I give you guys the example, another thing that you must remember is that in order to use integration by parts, you must also know this abbreviation. I almost forgot. This is a very important abbreviation. The everyone should know it. This one stands for logarithmic functions. So this abbreviation is gonna allow us to know what is u. And then I stand for inverse. A stand for algebra. T stand for trigonometric. E stand for exponential. Right. So now, let's say you're given. So remember that I said this one is the general formula. So I'm gonna show you how it works. We have the integral of u dv, which is equal to uv minus the integral of v du. So this allows us to choose what our u is. So now let's say you are given this product of two functions. So example number one, let's say you are having the integral of x ex dx. So let's say you are having this product of two functions, like x multiplied by e to exponent x dx. We're going to say let u be equal to. So we have to choose our value of u between these two. So because x is an algebraic, x falls under this one, and then e to exponent x is an exponential. So you must know the difference between exponential, trigonometric, and algebraic functions, inverse functions, and logarithmic functions. So the one that first is going to be your u. So we have x and we've got e to exponent x. So our u is going to be, we're going to let it be x because under this abbreviation of the algebraic functions start first. So our u is going to be x. And then we say du over dx would be 1. And then we say dv now is equal to e to exponent x dx. So this one, so this part is our dv. And then this one is our u. So now you'll integrate this side and that side. Then you'll have v equal to e to exponent x plus c. So we know that we're going to replace v with e to exponent x on our formula here. So now we can start integrating. We are looking for the integral of x dx dx. So here on this one, this substitution was not going to work. Hence, we have to use other methods. So the other one that's left will be integration by partial fractions. Only now you have two functions dividing each other. Let's say you want to integrate something like this, and your substitution is not wiki, so you will do that one later on. So now we're going to have u, we say this x, and then the value of v is what is e to exponent x. E to exponent x minus the integral of v, and then du. What is du? So du, you'll check it here. We'll have to make the u subject of the formula. So du, we know it's equal to dx. Since here we have 1, we'll do cross multiplication there. So now we'll have dx there. Then this will be minus the integral of e to exponent x is simply e to exponent x plus c. So this is our answer. We can as well take out e to exponent x as a common fact plus c for this question. Then let's go to another one. If you are having the integral of, let's say you are having e to exponent x, the sine of x dx. So here you're going to let u be, you go to the archer again, you check exponential is the last one, and then trigonometric follows exponential. So we're going to let u be sine x because t starts first. So we're going to have sine x, then we differentiate with respect to x, we'll get cosine x, and then you make the u subject of the formula, you will get cosine x. So you will do cross multiplication. So the u will be equal to cosine x times the x. Then now we know that the v is equal to sine x dx. So this one is the v. If this one is u, then this one is the v. And then you use the formula uv minus the integral of v to u. So now we are going to integrate this side and also integrate that side. So the integral of the v is v, then the integral of sine x is cosine x. And then now we can come to our given question. Then we replace u is sine x, then v is cosine x minus the integral of cosine x. The u is what? Is cosine x times dx. So this is going to be sine x. No, the value of u is what? We said u is sine x, and then v is cosine x. Yeah, it's fine. Why is it that we said u is sine x? Okay, u is sine x. U is this one, and then this one is supposed to be our dv. So yeah, let's fix this part. Dv is equal to what? E to exponent x dx. So I made a mistake there. So I hope you guys, yeah, you won't get confused. The remaining, since this one is our dv, then sine x is our u. So the remaining e to exponent x dx is dv. So our v is e to exponent x plus c. So hence here we'll put e to exponent x. I just made a mistake there. Then ex, then du will be cosine x dx. So if you check this one and this one, they are the same, right? So we can check this one to the left. So that's what we're gonna do. So if we take it to the left, we're gonna have 2 integral of ex sine x dx. And then this will be equal to sine of x e of x plus c. And then we're having 2 the integral of ex sine of x dx being equal to what? Sine of x sine of x dx. So just divide this side with 2 and also that side with 2. Then we know that our answer will be this. The integral of e to exponent x sine x dx will be 1 over 2 the sine of x dx plus c. So this will be our final answer. Now let's say we're having the integral of of x, the ln of x dx. So again, we're going to use the yard. So obviously here we have a logarithmic, which is ln x. So it's going to be our u. And then the v, we know it's going to be x dx. Then you just integrate. We'll have v being equal to x squared over 2, right, plus c. So this one will be our v. So now we can come and see, and come and have this dx. You know, we're using this formula, right? V du. So our u, we know it's ln of x. Our v is over 2. But we don't know what is the u. So we're going to, we know that we said we're going to let u be ln x. Then we differentiate ln x. So the derivative will be 1 over x. And then we make the u subject of the formula. So the u will be dx over x. So meaning that here we must replace with the x over x. And then we'll just have to Now simplify this part. So now we must simplify this part. So we'll have ln of x over 2x squared minus, so having the integral of x over 2 dx. And then now we're having what? 1 over 2 the ln of x times x squared minus, we check out the constant 1 over 2, and then we have x dx. So we'll have 1 over 2 the ln of x times x squared minus 1 over 2 x squared over 2 plus 0. So this will be our answer, right? Just have to simplify it further, and that will be 1 over 4 x squared plus c. When you multiply half and half there. So yeah, so this was gonna be our answer for that question. So now let's say they give you this one. Let's say they say integrate each exponent to x sine of 3x dx. So here you're going to let u be the yacht. You know that you're gonna say u is sine of 3x, because it's 3. And then we differentiate. This was gonna be the derivative of this is 3 cosine of 3x, and then the x will be, then the u. Here we are looking for the u. The u will be 3 times cosine 3x dx, and then the v will be equal to e2x dx. Then we integrate. Then we'll have v being equal to 1 over 2 each exponent to x plus c. So that's the derivative of each exponent to x. Then the only thing left will be for us to say from the original question. And then we substitute. U is sine of 3x. V is what? 1 over 2 e3x minus the integral of v is 1 over 2 each exponent to x, and then the u is this one, is 3 cosine 3x dx. So now we're here. So when we are here, we just have the integral of each exponent to x, the sine of 3x dx equal to 1 over 2 e3x, the sine of the. So here we have 1 over 2 each exponent 3x sine 3x, right? And then minus. Now we're having, let's check out the constant. So 1 over 2 is 3 over 2. 3 over 2, the integral of e2x cosine 3x dx. Meaning here you're gonna have to use integration by parts again. But if you notice this one, and this one, they're the same. Here, and this one. Why is it not right? and this one, they are the same. So we can take out one of this one to the left. So we're gonna have 1/2 the integral of e2x sine of 3x dx, because 1 minus half would be half there, would be this half. And then this is equal to -3/2 the integral of e2x cosine 3x dx. So now we'll have to apply, and then u, we know it's gonna be that one, right? We have to apply integration by parts again, and then v is gonna be what? 1/2 e2x, because you're gonna see the integral of the v of e to exponent 2x, then integrate, you're gonna get 1/2 e2x. Hence I'm writing it there, minus the integral of cosine 3x. Then now the derivative of, let me write it here. Now we'll look for the derivative of the v u, the u. We're going to see, we know that our u is cosine of 3x, then the u over dx is what is -3 the sine of 3x. Then the u will be -3 sine of 3x multiplied by dx. So that's what we're gonna write here. So we must replace the u from our formula with what? With -3 the sine. Okay, we'll have to reduce this. -3 the sine of 3x dx. Right. What is our value of what's happening here? The integral of u, or u will not. Okay. So now from here, let me copy this to the next page. This is what we are having, right? So here we know that we're using what? This formula, uv minus the integral of v du. Let's just confirm if I replace the value of v. Yeah, I didn't replace, so I must replace it. The value of v is what? It's 1/2 e to exponent 2x. Yeah, and then here would have dx. I could see even here you must insert it. Integral 1/2 e2x. So now we're gonna have, if we simplify this, and on the left we know we're having half. Put it there, we're having half the integral of e2x the sine of 3x dx. So we're having half the integral of e2x the sine of 3x dx. Then now we can simplify this. We're gonna get, this is negative. We're gonna get -3/2 cosine 3x, -3/4 cosine 3x e to exponent 2x plus. Then now we're using the integral of 3/2 the sine of 3x, yeah, e 2x dx. So these two, they are the same. So you take this one to the left. So we're gonna have 1 over 2 minus 3 over 2. This one will give us what? Negative, negative 1. So we're gonna get what is 1 over 2 minus 3 over 2.